This quick guide tutorial from exocad explains the crown bottom settings in detail. Important note: this part of the design and the parameters involved are crucial for a proper fitting. Please always discuss your intentions for adjusting parameters with your provider or milling center's support. In the 5-axis mode, you will notice that the arrows show individual insertion axes for each tooth, whereas the 3-axis mode enforces a unique insertion axis for bridges. Note that you will not always be prompted to define the insertion axis. A red arrow indicates that the insertion axis for this tooth might not be optimally defined and may need your attention. With a right mouse click on the tooth, you can always verify or change it. Rotate the view so that you look onto the preparation from the desired insertion direction. While rotating, undercuts are marked in red. Then click Set Current View as Insertion Axis to define the view as the new insertion axis. Once the insertion axis has been applied, the depth of the undercuts will be displayed corresponding to the color scale. Use the drop-down menu to switch to another tooth and correct its insertion axis. In the tooth bow, you can select a series of teeth with a click to define a unique insertion axis for those. Click Set Current View as Insertion Axis to define a unique insertion axis for the selected teeth, or check Unique Insertion Direction for bridges to choose a unique insertion axis for all connected crowns. Note that the software will automatically enforce parallel insertion axes for bridges if a material configuration for 3-axis, 4-axis milling is used. Now let's choose a unique insertion axis for the bridge and click the OK button to apply the changes to the crown bottoms. The red zones on the margin indicate areas which might create undercuts. This behavior can be changed in the Undercuts tab, which will be explained later in this video. Let's choose a custom view for tooth 16 to show the main cement gap parameters. The yellow area is the cement gap zone. It can be adjusted with the cement gap slider. And as you can see now, the new cement gap is computed in real time. The green zones on the dies and in the wizard indicate areas where there is no gap. The distance from the margin without cement gap can be adjusted with the slider from margin or by typing in a value. Furthermore, both zones can be defined with a brush. Click on the brush button for the zone you want to adjust. Let's try it with the no cement gap zone. With Shift and the mouse wheel, you can change the brush size. Extending the green zone without cement gap in the margin area will certainly increase friction. Use Shift to inverse the brush interactively. This allows you to delete brushed parts very easily. Click on the brush button of the other zone to brush and adjust the yellow area. Use again Shift to inverse the brush interactively. It is also possible to add an additional zone and to choose an individual cement gap for this separate area. This function could be used to increase the blockout thickness on sharp edges. Also here, you can use Shift to delete brush zones. You can also reset all markings. Some people might want to use the additional zone as a cement gap end with no spacing to avoid the rocking of big bridges. Maybe you already noticed that if you reset all markings, the distance sliders for each zone become active again. Now you can even define a distance for the blue area from the top. You can again adjust the cement gap thickness in this zone. The blue cement gap zone will disappear if you choose 0 as a distance. Additional spacing allows you to add additional offset spacing to the entire crown bottom, independent of the cement gap. This means that the cement gap will be applied on top of the additional spacing. The axial spacing will add offset in occlusal direction. The radial spacing will add offset perpendicular to the occlusal direction. Both sliders are locked so that offsets are added equally spaced to the 3 axes. The higher values are here, the looser the fitting. Setting this parameter to 0 means that the green area and the margin will have no gap. Some people might want to use the parameters to create a thin gap in the green area. But it is important to know that these values will be applied in addition to the cement gap. In this case, this would result in a real cement gap in the yellow area of 0.11 millimeters. It is recommended to keep both sliders locked to ensure equal space in all axes. Nonetheless, you can unlock the sliders and set an individual parameter for each. You can also use negative values to create a tighter fitting. The result would be a crown that has a smaller bottom than the die. Note that negative settings may lead to manual work on the restoration. However, trying to improve the fitting by changing the additional spacing values is a workaround, not a solution. A properly tuned cam system should be able to achieve good fittings with minimal additional spacing. Let's have a look at the border settings. I've prepared a sectional view which will help us to understand how the border shape can be influenced. The graphic illustrates the meaning of the sliders. Horizontal defines the horizontal crown border width. Typically, material properties enforce certain limits here. For example, for zirconia, the common minimum value is 0.2 millimeters. Angled defines the length of the border's angled part. This is commonly set to 0 for metal. Angle defines the angle for the angled part. Vertical defines an additional vertical border. Commonly, this value is also set to 0. Below margin defines an absolute offset for all the drawn margin points in the insertion direction. The third tab in the Crown Bottoms dialog provides undercut-related options and milling parameters. Another sectional view will help us to understand the undercut and milling parameters. Per default, undercuts are blocked out in the preparation unless you check Don't block out undercuts. Note, changes in the undercut settings always have to be applied. Now you see that undercuts are not blocked out. Let's again look at the preparation when undercuts are blocked out. Here is the default situation with blocked out undercuts. Undercuts are always blocked out parallel to the insertion axis, unless you explicitly choose an angle that should be applied for blocking out undercuts. For instance, this might be done when conical tools are used in the cam. Let's come back to the default settings. The slider Don't Block Out Zone near prep line defines an untouchable zone around the preparation margin, where the crown is never blocked out. You see now how the upper part is blocked out, but as soon as the untouchable zone is reached, the crown bottom will go back to the preparation. Note that these settings may create undercuts in the crown bottom, marked in red. It might not be possible to produce this kind of restoration with 3-axis milling. The default value in our generic version is 0.1 millimeters. This means that just a very small area at the crown margin has not been blocked out. Now I will demonstrate the behavior with Don't Block Out Zone near prep line set to 0, a setting commonly used in 3-axis mode. As you can see, the crown will not be in contact with the preparation along the margin. These gaps are marked in magenta. In 5-axis mode, I recommend to set this value equal to the cement gap distance. This helps to ensure that the crown is completely in contact with the preparation in the green area. Let's switch back to the sectional view. We will now have a look at the Anticipate Milling feature. This feature will add a tool diameter compensation to the cement gap for sharp edges. If you have selected a material for milling, it is checked per default. If unchecked, no tool compensation will be computed, and sharp edges are just blocked out with the cement gap. Use the Diameter slider to define the diameter of the smallest tool that is used in milling the crown bottom. It is beneficial to choose a value slightly higher than the diameter of the actual tool you are using. For example, choose 1.2 millimeters when milling with a 1 millimeter tool. The Bullnose Flat Tool checkbox enables a tool compensation for flat cylindrical tools instead of a spherical tool shape. Tooltip flat percentage should be used to adjust the tool shape. Here is a graphic to explain the percentage value when the bullnose tool is used. Changes in the undercut settings always have to be applied. The tool compensation looks flat now. Let's come back to the default setting. The button Show Undercuts leads to the cement gap undercuts being displayed with a color scale. Note, if at any point in this step you find that the insertion axis is not optimally defined, you can still easily change it in the right mouse context menu. Now you can proceed to the next step. The software's exact blockout behavior depends on the material configuration provided by your system integrator. In most material configurations for 5-axis milling, the cement gap is applied after doing the blockout. This means that for step preparations, generating the cement gap itself may cause new undercuts. In 5-axis configuration, very often a defined zone near the margin line is not blocked out. This also could cause new undercuts in the margin area. But that is fine. A 5-axis machine can produce these and it will give an optimal result. In the standard 5-axis configuration, changes in the cement gaps will usually be computed and visualized in real time. For 3- or 4-axis production, material configurations typically define an additional blockout being applied after generating the cement gap to avoid any undercuts that 4-axis machines cannot mill. For the same reason, undercuts are very often blocked out all the way down to the margin using a value set to 0. But this configuration could create gaps in the crown border. As already mentioned in this tutorial, such gaps are to be indicated with magenta color on the borders. Note that computing the blockout of the cement gaps with 3-axis configuration is a computationally intensive operation and cannot be done in real time. Therefore, when adjusting the parameters, you might be prompted to click Preview Result after blockout to preview the result, including the blockout. Thank you for watching this video.